All right, in the Using Prime Trig Ratios worksheet, we're going to take a look at how we can use our prime trig ratios to calculate or determine the lengths of unknown sides in right-angled triangles. But before we can start doing that, we need to figure out which one of the trig ratios is going to most benefit us. So if we are looking at a right-angled triangle, so we'll take a look at this right-angled triangle over here, and let's say that we know what the hypotenuse is. Let's say we know that it's 10, and we're asked to determine what the opposite side is. When we label our right angled triangle, which is something that we should always be doing, this is the angle right here, our focus angle. So this is the opposite side, this is the hypotenuse, and this is the adjacent side. We would be focusing on a trig ratio that includes opposite and hypotenuse, and we don't really care about adjacent. And from SOHCAHTOA, which is SOH, CAH, TOA, we can see that the only trig ratio that contains both opposite and hypotenuse is the sine function. So for this case, we would use the sine function to determine the length of the opposite side. All right, let's go down to the exercises. The first thing that we need to do is label our diagram. So down here we're given our angle of 40 degrees. So when we label this diagram, we know that the side opposite the 40-degree angle is the opposite side. This one over here is always the hypotenuse, and that means that this has to be the adjacent. We're asked to find out this, which is the opposite, and we're given this, which is the adjacent. So which one of the trig functions, so again, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent, which one of these trig functions includes both opposite and adjacent? And you'll see that that's the trig function that we'll end up using. For this first question, we know opposite is x, and we know our adjacent is 12. So we're going to actually use tangent. So tan of our angle, which is 40 degrees, is going to equal opposite over adjacent, which is x over 12. Now, we can use our calculator. Let me just pull that up. We can use our calculator to determine what tan of 40 is. So let's do that. So I'm typing in 40 first, trig drop down, and then click on tangent, and I get 0.83909. So it's going to actually be 0.8391. And we have 0.8391 on this side of the equation, and on the other side of the equation we have x over 12. And now what we're going to do is we're going to cross multiply to move the 12 over to that side to get x by itself, and we have 12 times 0.8391 equals x. When I typed this in on my calculator, I ended up getting x equals 10.0692, and when I round that to one decimal place, I ended up getting 10.1. There's another way that we could have done that without actually calculating tangent of 40 first and writing down 4 decimal places. We could have done it all in one step on our calculators. We have tangent of 40 degrees equals x over 12. And now what we're going to do is we're going to multiply both sides by 12. Basically, we're cross multiplying here, and we end up getting 12 times tangent of 40 degrees is going to equal x. Now let me show you how you can type this in on your calculator. Now again, the Windows calculator is a backwards calculator. So that means that I have to start with the 40 degrees. So I'm going to go 40, and then I'm going to go into my trig functions and tangent, and now I'm going to go times 12 and equals. And you'll see that I get 10.069195555. Basically, I get the same answer, but I did it all in one step. Now, let's take a look at the second triangle. Here's my angle down here. I have to label my diagram, which is the first step always. This is opposite, this is adjacent, and this is hypotenuse. I know that I'm looking for the hypotenuse, and I'm given the opposite. I have no use for or any information of the adjacent side. So I'm going to be using a trig ratio that includes opposite and hypotenuse. And when I go up here, I can see that sine is the one that includes opposite and hypotenuse. So I'm going to be using sine. So the opposite is 12, and the hypotenuse is what I'm looking for. I write my trig ratio, and I start off with sine of theta equals opposite over hypotenuse. Fill in what I know. I know that theta in this case is 35 degrees. The opposite is 12, and I'm looking for the hypotenuse. Now I'm going to do cross multiplying, which means that the x is going to move up to the top on that side, and the sine of 35 is going to move to the bottom on the other side over here. So I end up getting x is going to equal 12 divided by sine of 35. So let's calculate what sine of 35 is going to be first. So I'll bring my calculator back up. And so I type in 35 and then trig and sine, and I get 0.5736. Now on my calculator, I'm going to go 12 divided by 0.5736 equals, and I end up getting 20.9205. I only need to keep one decimal place when I get to my final answer, and I'm doing a side length. I end up getting x equals 20.9. All right, your turn. Give this one a shot. What I did here was, because the angle that we are focused on is down on the bottom, that makes this side over here the opposite, this is the adjacent, and this is the hypotenuse. Now, we don't really care about the opposite here because we're not given any information and we're not looking to find that, but we are looking to find the adjacent, and we're given some information about the hypotenuse. So that means that the trig ratio we're going to be using is the cosine ratio. So I started off by writing down my formula, and I plugged in what I know. I ended up getting, after cross multiplying, I get 13 times 0.8480, which is what the cosine of 32 equals. And when I multiplied those together, I ended up getting, rounded to one decimal place, x equals 11.0.